Okay, in example 3, we're going to be solving a half angle. And so again, the first thing that we do is we isolate the trigonometric expression on a side by itself. I want to get that square root of 5 off of there, and that can be accomplished if I divide both sides by square root of 5. Now my equation looks like the cotangent of x over 2 equals square root of 5 over square root of 5. Well, that's just a fancy way to write 1. The next thing we're going to do is take the inverse cotangent of both sides. Now, when we do that, the left-hand side is just going to be x over 2. But when we take the inverse cotangent of both sides, on the right-hand side, we have the inverse cotangent of 1. So what we're going to do now is we're going to generate a list of angles that have a cotangent value of 1. All right? Now that's going to happen in 2 separate quadrants. For cotangent, the cotangent is going to be a positive 1 in quadrant 1 and also in quadrant 3. Okay? Now, so I'm just going to bring down the left-hand side. X over 2 equals on both of these. Okay? And then on the right-hand side, I'm going to think about what are all the angles that have a cotangent value of 1. Well, these will be the same angles that have a tangent value of 1 over 1, which is 1, right? Right? When the reciprocal of 1 is 1. Okay, and so those angles are like 45 degrees, right? The tangent of 45 degrees equals 1. Well, I'm not going to do 45 degrees. I'm going to do pi over 4 plus 2 in pi. Every time I hit that 45-degree angle in quadrant 1 and then also in quadrant 3, that would be 5 pi over 4 plus 2 in pi. Okay? Now, remember that because all sorry teachers cuss, that when you're dealing with tangent or cotangent, let's say you get an angle right here in quadrant 1, you're also going to get an angle down there in quadrant 3. And so actually you can make this a little bit more concise to write all of that all together. Okay, x over 2 will be equal to, let's just do pi over 4 and then just plus 1 in pi. Now that is going to allow us, that expression right there says it's going to be pi over 4 plus 1 pi will get us 5 pi over 4. Okay? Pi over 4 plus 2 pi will get us back up here. Pi over 4 plus 3 pi, 1, 2, 3 pi, will get us back down here in quadrant 3. So do you see why this pi over 4 plus 1 in pi will work for tangent and cotangent? Okay? All right, now the last thing that we need to do to finish up our problem, to write the general solution set, is we need to do a little bit of algebra to solve for x. We can solve for x by getting rid of that divided by 2. This means I'm going to multiply everything through by 2. Okay? Now when we do that, we have x is equal to 2 pi over 4 reduces to pi over 2, and then nothing to reduce here, so it's just 2 in pi. So that is going to be the solution set for the general solution. It's the set of all x values such that x is equal to pi over 2 plus 2 in pi. That's it. Now for part B, when we go to write the solution set just for one rotation in the positive direction in between 0 and 2 pi, Let's see, in my little formula above, when I let n be equal to 0, I have x is equal to pi over 2 plus 0 pi, which is just going to be pi over 2. Keep going until we get beyond 2 pi. When n is equal to 1, my formula above says x is equal to pi over 2 plus, when n is 1, 2 pi. And pi over 2 plus 2 pi is going to be greater than the 2 pi. So we don't need to include that answer. It's outside of this given interval here. All right? So our only solution set on that interval is just going to be pi over 2. That's the only answer. Okay? So there's my general solution set. Here's the solution set for all values that would satisfy our equation just in between 0 and 2 pi.